This final year engineering project has been completed at DHSOFA University's Department of Electrical Engineering. It is titled as Embedded System Implementation of a Speed and Torque Controller for AC Machines using the Vector Control Strategy. Vector control is a very dynamic and robust control strategy with widespread industrial applications. If we talk about electric vehicles, if we talk about electric traction, the electric motors that are used in electric vehicles or that are used in electric trains, their speed and torque has to be controlled in a very fast and dynamic manner, and vector control strategy has got advantages over other control strategies, and it is typically used in AC machines that are used in electric vehicles and in electric trains. If I describe vector control to you, in the vector control strategy, flux and torque of the AC machine, they are controlled in a decoupled manner. The D component of the stator current vector controls the flux of the AC machine, whereas the Q component of the stator current vector controls the torque of the AC machine. And wherever a more dynamic and quick speed and torque response is needed, the vector control strategy takes precedence over other control strategies such as the volts per hertz control strategy or other control strategies that are often used to control AC machines. So in this final year project, the vector control model that the students have simulated, you can see that the AC motor whose speed and torque is being controlled, first its three-phase currents are measured, and then those three-phase currents, they are converted from the three-phase system to the two-phase alpha-beta coordinate system. The alpha-beta coordinate system is actually the stator's reference frame, and from the alpha-beta current components, those current components are then converted to the DQ system. So we have a current component which is the D current component of the stator current vector, and we have a Q component of the stator current vector, which is ISQ. Now in vector control, the D component of the stator current vector is used to control flux, and the Q component is used to control torque. So there are two PI current controllers, and there is one speed controller whose output generates the reference value for the Q component of the stator current vector that eventually decides the torque of the machine. So, and there is a speed controller, whatever reference speed you would like the motor to achieve or track, that is given as an input. So students have simulated this model on Simulink, and very briefly I'll just open that Simulink model. So that entire block diagram that I just showed you, students have simulated this on Simulink.